So the graph of a one-to-one function is shown to the right. So draw the graph of the inverse of the function. So one of the catches with inverse functions is they do have to be one-to-one functions. So that's why they're saying this is a one-to-one function. So if we look at the graph of the, so we have this little blue graph over here. Notice that it does pass the vertical line test, first of all, to be a function. It does pass the horizontal line test to be a one-to-one function. Now, this line y equals x is here because the graph of a function and its inverse are going to be symmetric to the line y equals x. So they're actually going to have this symmetry here. So again, when graphing the inverse, what we want to do is we want to switch the rows of x and y. The two functions will be symmetric to the line y equals x. So if I look at the function given, if we can identify some ordered pairs, we see that there's a -3, -3. There's 0, 0. And then there's this 3, 9/16. So the inverse function, to graph it, as I said, that there's this backwards thinking. So what happens is the y has become the domain. So the -3, the 0, and the 9/16 become the domain values. And then the domain values become the range values or the y values. So if I graph those ordered pairs, this is going to graph the inverse. So if I graph -3, -3, it's still the same spot. 0, 0 is still the same spot. And then 3, 9/16 is now going to be 9/16, 3. So 9/16 is a little over half. So not, you really won't tell much difference here. Just basically a half, if you will. Such a big dot. So notice how these points are going to be symmetric across the line y equals x. So that means this graph here is going to have to kind of be symmetric as well. So it's going to have to come from this direction here. And then when it comes across here, this part here is going to get reflected across the graph as well. And the graph should kind of look symmetric to itself. So these points should all be mirrored across the line y equals x. So you should have a graph that kind of takes on this look here. So which one of these kind of takes on that look? It looks like this one here does the best. So I do see that symmetry happening here. I'm not seeing that symmetry happen with these other ones. So that's the key to the inverse function, is the rows of x and y are going to switch. The rows of x and y are going to switch. That's going to be a very powerful piece in working with inverses.